Hi everyone, this is Mehak Beniwal and this is my video demonstration for task 7.3D from SIT 210 Embedded System Development. Let me first tell you the objective of this task. The objective of this task is to utilize pulse width modulation on Raspberry Pi so that when an object approaches the ultrasonic sensor, the brightness of the LED progressively increases and then it slowly fades away when we move our hand away. I would like to tell you more further about pulse width modulation. So let us understand what is pulse width modulation. This is a modulation technique which creates pulse of variable width to represent the amplitude of an analog input signal while keeping the frequency constant. This is done by timing on-off signals so that this PWM technique can be used to adjust the power delivered to the load. This technique can be used for different things to vary the intensity of light. So now I would like to tell you about the components. The components used are Raspberry Pi with 330 ohm, 1000 ohm, 2000 ohm resistor and an ultrasonic sensor. So now let us look at the code. First, we have to import the libraries as RPIO, RPIO.GPIO as GPIO pins, which help us to communicate through the GPIO pins. Then time library is imported because of ultrasonic sensor, as we need time ability to calculate the distance that we are setting for our GPI pin to GPI board. And then we have defined some global variables, that is trigger pin with pin number 18 and echo pin with the pin number 16. In the line number 15 we can see that GPIO.setup. In this line we have set up the trigger pin to output, and in the next line we have set up echo pin to input. And after that an instance is created of our PWM in which we have passed LED pin and frequency, and then we initialize the PWM with a duty of cycle. Now we can see that we have made a function named distance. From this function we will calculate the distance of object from the ultrasonic sensor. First is we have to set the trigger pin to high, which will send the pulse, and we have time pin high for 10 microseconds, and after that it is set to low. And after that we will record the last load for echo pin, and then we will wait for the wave to come back, and it will record the time of wave upgraded received by the sensor. And in the line 36 we can see that time elapsed. We have given a value that we have to subtract the stop time from start time, and then we get the desired duration of other pulse travel from the sensor to the object, and then back it to again. Now we will calculate the distance using this formula, that is time into speed, and the speed is 34,000. The speed is 34,000 because the sound wave travels at 343 meters per second, so it will be 34,300 centimeters per second. Then it is divided by 2 because the distance we are getting using this formula will be divided by 2 because it flows from ultrasonic sensor to object, and again then it come back to it. And in the line number 39 you can see that the distance is returned. Now you can see that we have made a code block, that is try except code block. This is an infinity loop using to calculate the distance. So in this you can see that if it is true, then we have to print the measured distance is equal to the following distance in centimeters. And in the next line number 47 we can see that if the distance is less than 100, then it will change the width of the pulse. So I want to tell you how it will change the width of the pulse, because change duty cycle is the function which can change the width of the pulse, and it is very useful for us in this. And I think I have told my code in a very good manner. And next, my video demonstration is up.